The full accessory power active warning is becoming increasingly common in modern vehicles. This message indicates that your car's electrical system is providing power to accessories like the radio and lights, but the engine isn't starting. When you see this warning, your car's accessories are receiving power, but something is preventing the engine from starting. The radio, lights, and air conditioning work normally, but the engine remains silent. This issue is particularly common in vehicles manufactured after 2018. Modern cars have become incredibly complex, with up to 150 electronic control units compared to just 20 to 30 in older vehicles. There are four primary causes of this issue. Battery problems account for 60% of cases, including insufficient voltage, internal cell failure, and corroded terminals. Starter system issues make up 25% of cases. Ignition system failures, such as defective ignition switches or dead key fob batteries, cause 10% of cases. Electronic control module glitches account for the remaining 5%. Battery problems are the most common cause. A healthy battery should maintain at least 12.4 volts at rest. Issues include insufficient voltage, internal cell failure, corroded terminals as shown here, and age-related capacity loss. Starter system problems include a faulty starter motor, worn solenoid, or poor electrical connections. The starter motor, shown in this cutaway diagram, must engage properly to turn the engine over. Modern vehicles have incredibly complex electrical systems with intricate wiring networks. Communication errors between modules and software-related failures can prevent proper starting sequences, making diagnosis more challenging. Understanding these causes helps prevent the full accessory power active issue. Regular battery maintenance, keeping terminals clean, staying current with software updates, and professional diagnostics when needed can help avoid this frustrating problem. To resolve full accessory power active issues, follow this systematic 5-step diagnostic approach. Each step builds on the previous one to efficiently identify and fix the root cause. Step 1 is battery voltage testing. A healthy battery must maintain at least 12.4 volts at rest. Use a digital multimeter to measure voltage across the battery terminals with the engine off. Follow these steps. Connect the multimeter leads to the battery terminals, set to DC voltage measurement, and record the reading. If voltage is below 12.4 volts, the battery likely needs replacement. Step 2 involves inspecting and cleaning battery terminals. Corrosion creates electrical resistance that prevents proper current flow, leading to starting failures even with a good battery. Clean corroded terminals using this procedure. Disconnect the battery starting with the negative terminal, apply baking soda solution to neutralize acid, scrub with a wire brush, rinse thoroughly, and reconnect positive terminal first. Step 3 uses OBD2 scanning to check for error codes and verify communication between electronic modules. This method achieves a 91% diagnostic success rate compared to visual inspection alone. Look for these common codes. P0562 indicates system voltage is too low, P0563 shows voltage is too high, and U100 means communication is lost between control modules. Step 4 checks for software updates and manufacturer recalls. The Ford F-150 case study shows how a simple software update resolved widespread accessory power issues with an 89% success rate. Always check the manufacturer's website for recalls and technical service bulletins before replacing expensive components. Many issues can be resolved with free software updates at authorized dealers. Step 5 involves component replacement based on diagnostic test results. Battery replacement resolves 45% of cases, while starter issues account for 25%. Always diagnose before replacing to avoid unnecessary costs. Future automotive technology will use AI-driven diagnostic systems to predict full accessory power, active issues before they occur. By 2025, these systems are expected to achieve 85% accuracy in failure prediction, enabling proactive maintenance and reducing unexpected breakdowns.